Hypothesis testing. Now, we all know that a hypothesis is a proposed answer to the research question based on limited evidence. Hence, data has to be collected in order to test its veracity or truthfulness, because basically a hypothesis is like an opinion. Okay, so it has to be tested. There are two main approaches to test the hypothesis: the critical value or classical approach and the p-value approach. If the critical value approach, you are to compare a test statistic calculated using sample data with a critical value on a distribution curve, whereas the p-value approach, which can be done manually or Excel or any other software, JASP. In this approach, you are to use a test statistic calculated from sample data to obtain a p-value. That's a probability value by sample data from statistical tables or software. And then you have to compare that p-value now with a significance level called alpha, which is another probability value determined by established research. So here we're going to outline the steps for p-value approach using Excel, SPSS, Minitab, R, JASP, VASA, Stats, or any other software that you are using. First, you identify an appropriate hypothesis test based on the situation you have. So it could be a z-test for mean, or it could be a t-test. All right. Now you have to also state a pair of hypotheses. The pair of hypotheses is either called the HO, which is the null, or the HA or H1, which is the alternative. Now these hypotheses are statements based on the population mean. Okay. Now you also have to establish a significance level called alpha. Alpha could be 0.01, 0.025. It's very common to use 0.05. Now you have to input the data in Excel or SPSS or Minitab or JASP or whatever software that you are using. You put the data in it. Then you have to process that data, and the software that you're using will give you an output. Now you have to identify the p-value from the output, okay, that the statistical software gave you. And then here now you have to compare that p-value now with the significance level that you started with. It could be 0.05. Now, if the p-value is less than the significance level, you reject the null, okay? If the p-value is not less than the significance level, if it is greater than, all right, than the significance level, then you do not reject the null, okay? And there are two errors that you can make, either type 1 error, that's if you reject the null and it is true, or you can make a type 2 error if you did not reject the null and it is false. Now you have to conclude. Remember, you started with two statements, the null and the alternative. So if the null is rejected, then the alternative is the conclusion. But if the null is not rejected, then the null itself is the conclusion. So always remember that you will start the test with two statements, the null and the alternative, HO and HA or H1, the null and the alternative respectively. And after the test is done, only one will be the conclusion, either the null or the alternative. Here's a diagram with different hypothesis tests that are commonly used. You have the parametric and the non-parametric, one sample, two samples, one sample, two samples. Here we're going to outline an example using a t-test, a one sample t-test parametric test. Okay, that's what we're going to exemplify here. Now here are the hypotheses for the one sample t-test for population mean. Now the population mean is given the symbol mu because the English M was already used for gradient. So the mathematicians went to the Greek alphabet and used the equivalent to the lowercase m in Greek, which is mu. So if you have to spell mathematics in Greek, you start with the capital M, which is like our English M. But the other M, which is a small m, you'd have to use mu, and here it is, mathematics, mu. All right, so that's what the mathematicians use to symbolize the population mean. Okay, the Greek letter mu. Now you have scenario 1, 2, and 3. Scenario 1, the HO can be seen, the mean is equal to a certain value and the mean is not equal to a certain value. And here is the symbolic translation. Scenario 2, the mean is equal to a certain value, the mean is less than a certain value, and here is the symbolic translation. And scenario 3, the mean is equal to a certain value and the mean is greater than a certain value. Here is the symbolic translation, because you must start the test with a pair of hypotheses. Okay, that's what you test in, hypothesis. So you must start with it. So either one of these scenarios, that's what you start with. And we're going to do a one sample t-test in Excel. So here's the setup already for the one sample t-test. We have a one sample of scores, and then we have the setup here. The HO, the mean scores of group B, is equal to 85%. The mean scores of group B is not equal to 85%. And here are the symbolic translation. So it appears that we are using scenario 1. The mean is equal to and the mean is not equal to. Now the not equal, bear in mind, is the two-tailor. The less than and the greater than, the arrowhead is all pointing to one direction. So these are one tails. Less than and greater than are one tail, but the not equal is a two tail, because the not equal is not pointing in any direction. So it's a two-tail test. So here we are going to be doing a two-tail test, equal to 85, not equal to 85. Now, we have to remind ourselves that we're going to reject HO, the null. We reject the null if the p-value is less than the significance level of 0.05. We're using 0.05 as our significance level. Now, we have to conclude if HO is rejected, then H1 is the conclusion. All right, this will be the conclusion if we reject HO. But if HO, here it is not rejected, then HO itself is the conclusion. So now, in order to know if it's to reject or not to reject HO, we have to get the p-value. So we have to get the output. And to do that, now we go to data and we go to data analysis. If data analysis is not in your Excel, you can add it. You can look at a YouTube video of how to add the data analysis in Excel. Click on data analysis, and Excel now does not accommodate for one sample. It only accommodates for two samples. So that is why now we have to create another variable, and you must put at least 2 zeros in it. Not one, at least 2 and up. Okay, you must do that. A kind of fake variable to full Excel that is a two sample test that you are doing. Okay, and we click on two sample, assuming unequal variances, because we don't know the variances. So we are assuming that they are unequal. And you click OK, and you highlight the first variable range from A1 to A8, and the second variable 2 range from B1 to B3. Okay, and the hypothesized mean difference, we put it as 85. The hypothesized mean difference. We click labels because we actually started from A1 and B1. And the alpha, the significance level, is 0.05. So we leave it at 0.05 because it comes default as 0.05. And then we click OK. So here Excel gives us the output in a separate spreadsheet. So since we are doing a one-tail test, then we can delete this column. Okay, right-click and delete this column here. And we look for the p-value two-tail. Here it is. The p-value two-tail is actually 0.365. Okay, 0.365 is the p-value two-tail. Here is the mean, the sample mean. We got the sample mean to be 88, and our hypothesized mean to be 85. So you can see 85 is not so far from 88. Okay, our sample mean is 88. All right, and the hypothesized mean, not mean difference, the hypothesized mean, we put it at 85. So we're saying that the mean is about 85. The population mean is about 85. That's what we hypothesizing. And the sample mean gave us 88. And the p-value now, a two-tail p-value of 0.365. Now, when we go back to our setup, we realize 0.365 is greater than 0.05. So since 0.365 is not less than 0.05, we do not reject the null. Okay, so we do not reject that null statement there. And actually, it kind of makes sense because 88, which we got from the sample, is not so far from 85, which we hypothesized. All right, so then we can make our decision since 0.365 is greater than Right, that's what we're doing. .05. All right, it is not less than 0.05. We do not reject the null. Right, so since we do not reject HO, here is HO, then HO itself is the conclusion. And we have to write it in words. So we can just copy this as the conclusion. The mean score is equal to 85. Okay. The population mean score is equal to 85. If we had put a hypothesized mean of, let's say, 50, okay, let's say we go back here and we put a hypothesized mean of, let's say, 50 instead of 85. Now, 50 now is very much different from 88. Okay, so as you can see, Excel will give us a very small p-value. Here it is. That negative 0.05, e to the negative 0.5 means you have 5 zeros, 1, 2, 3, 4, 5, and then the 1, 6, 7. So as you can see, this is very much smaller than 0.05. Then we'd have to reject the null. If we had used 50, we'd have to reject the null, and then the alternative will be the conclusion that the mean is not equal to 50. It is actually equal to about 88 thereabout. Okay, but because we use 85, 85 is kind of close to 88. So, you know, Excel did not allow us to reject the null, which is saying equal to 85. Okay. So we conclude that the mean, the population mean scores of group B is about equal to 85%. We got 88 in the sample, so 88 is not so far from 85.